Welcome to the first AP Physics 1 practice problem video where I will go through AP Physics 1 and eventually 2 past exam problems that closely correlate to the current examination method problems given by the AP exam. So you won't see any more paragraph-length responses, nor will you see any more short-length questions anymore. So you'll be given 25 minutes per FRQ now. All right. So the first thing when you see a question, any question really, is you have to first look at what this question could possibly be about. Well, I'm looking at two moons and a planet. That sure seems gravitational to me. And when I think about gravitation, I'm thinking of Fc is equal to Fg. I'm thinking of Newton's third law tricks. I'm thinking about rotational mechanics, such as the conservation of angular momentum. You've seen this on your test, so you kind of know what you're in for. All right, so the next thing that you should also do when you do such problems like these, and really problem any, is to find out freebie marks that you can earn. Part A is a free body diagram question, so that should be relatively simple. Normally, FBD diagrams aren't too hard to draw and are free marks for you to earn. And question B appears to be difficult because you have to consider what could means and what this entire problem actually is. And it really is a hypothetical problem, which is quite difficult for the AP exam. So I would skip this question and look at what question C gives us. Now, question C seems to be much more approachable because we're really dealing with, it seems to be just gravitation. Well, if it's just gravitation, it should be doable, but it's still not as easy as part A, so I'd probably do that first. And then when I look at part D, I definitely know I'd be saving this problem for last, because this problem directly correlates to what I need to do in part C, so I'll be saving that till the very end. Alright, so while for this problem we have to do it chronologically, don't hesitate to do other problems or other questions in other problems, not in a chronological order. It's more satisfying to be able to do all the problems eventually than to realize that you've run out of time and there are still questions that you still could have done for free marks, but unfortunately you ran out of time, so you lost the marks and you got a 3 on the exam instead of a 5. So let's not make that happen. All right. So for part A, we have to draw the free body diagram of the forces exerted on Moon A and Moon B. Well, this should be relatively obvious. Moon A will be attracted to the right by vectors of the gravitational force by Moon B and the planet. So we'd be drawing two vectors here. And obviously, we should realize that, well, Moon A will have two forces going to the right, and one force will be much greater than the other, and that is the force of gravity provided by the planet, because it has a greater mass, as given by the problem. And it will have a lesser force of gravity exerted to the right, given by Moon B. Now, for the forces exerted on Moon B, Moon A will be attracting it to the left with an equal and opposite force of FGB, due to Newton's third law. And the force exerted on the planet, force exerted by the planet on Moon B is actually much larger because RB is actually much greater, much smaller than RA, which means that the force of gravity will be much greater exerted on Moon B than on Moon A. All right. So now that we have part A sorted out, let's move on to part B. Now, sometimes I would actually do part C first because it's more mathematical, but I'm feeling like I could tackle part B because it honestly isn't too long. Alright, so for part B, we have to justify why the magnitude of a net force exerted on Moon A could be larger than the magnitude of a net force exerted on Moon B. For these hypothetical questions, I like to think about crazy scenarios that are basically impossible in the universe, but are definitely valid in the problem. Well, how would I know what scenario to imagine? Well, I have to first think about part A once again. We notice that these two vectors are constructive, while these two vectors are destructive. Now, if in the very hypothetical, if FGA is large enough to the point where it could almost completely destruct with FGP, while Moon A is purely just having vectors that are going to the right, that will mean that Moon B will barely have any net force exerted on it, then compared with Moon A. Well, how could that happen? How can we make FGA be really large and FGB be very large? Well, the solution is simple. We put these moons super duper close together. And when we put these moons super duper close together, the gravitational attraction will be very large. Okay, so we already know what a potential setup could be now. So we could say that if Moon A is very close to Moon B, then the gravitational forces between the moons will be very large, even larger than the force of gravity exerted by the planet. The forces that Moon B concurs will be destructive, while the forces on Moon A will be constructive, meaning the net force on Moon A will be greater than the net force on Moon B. And there we have it. That is our first answer to part B. Okay, now when we're dealing with part BII, we should think about the other hypothetical scenario. Well, it's asking for a net force where Moon B is much, much larger than the net force exerted on Moon A. Well, if we have the two moons super far apart and Moon A be really, 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 really far apart from the planet, well, then Moon A will basically experience no net force. And if we put Moon B very close to the planet, well, it'll experience a much, much larger force than Moon A will experience. So we should write, if Moon A is very, very far from Moon B and the planet, its net force will be approximately 0. Now, if Moon B is super close to the planet, it will experience a net force that is far larger than the net force exerted on Moon A. All right, so these are two hypothetical scenarios that we can be dealing with. So that's really how we could answer question B. And now let's move on to question C. Now we have to derive a net force A exerted on Moon A. So note that this isn't the force that Moon A exerting on the other moons and the planets, but the net force that Moon A is experiencing. Okay, the first thing that we should definitely write out is our Fnet expression, but luckily we don't actually have to write an Anet expression, so we don't actually have to write Fnet is equal to MAnet. What we really need to write is how these vectors construct or destruct. So we write that Fa will be equal to, we should be consistent in how we labeled our vectors on top in part A, force of gravity exerted by Moon B, plus the force of gravity exerted by the planet. All right. Now, when we have this, all we really need to do is sum up the vectors that are exerted on both of these planets. And that really isn't too bad. We simply need to plug this into our equation that Fg is equal to G big M small m over the distance separating the two planets. So we're already given all of these properties. So it really is just a plug and chug business. So we know that FGB is simply MO, and that'll be MO naught because M naught times M naught is just M naught squared. And we have our gravitational constant G, and that will be divided by the distance between them. And now note that that isn't RA nor RB, but that's actually RA minus RB and then squared. All right? So don't miss out on that because you're taking the distance between the two moons. So that would be RA minus RB. And don't forget the squared sign. All right, so that's one expression. Now we have to derive the expression for the planet. Well, for the planet, that's not too bad actually. All we really need to do is observe Moon A and realize that it is a distance RA away from the planet. So now it's really just a plug and chug business of realizing that that's just G multiplied by M naught multiplied by the mass of the planet divided by the distance separating the two celestial bodies, which is RA, and then we square it. And that's it. That is our solution to C1. All right. Now, to deal with our second part, the net force FB exerted on Moon B, we should realize that due to Newton's third law, FGB is really the same as FGA. So FB is equal to, we know that in theory the planet should win, so let's just put FGP in front. FGP minus the force of gravity exerted on exerted by planet A. Newton's third law says that these two values are actually the same, so all we really need to do is actually simply copy and paste this expression term in. So we have G M naught squared divided by RA minus RB squared. Okay, that was easy. Now we have to deal with a gravitational attraction between Moon B and the planet. Well, they're separated by a distance of RB, so it really is just this expression, but we swap out RB instead of RA. So we add the minus sign in front, we have G, and we have M naught, we have MP, divided by RB squared. And that is our solution to part 2 of a problem for part C. Okay, so that was relatively straightforward, hopefully. If not, please take a look at the slideshows that have been posted on the Google Classroom. They are super helpful. Now, for part D, we really need to look at how these expressions are consistent with our answers in part B. So let's look at how part C can support my reasoning in part BI. So we're really looking at this expression. So in part BI, we said that if Moon A is very close to Moon B, then the gravitational forces would be very large. And while this could be very large, if FGP is large enough, then FB would be 0. So what I mean is, there is a certain distance where Moon B can be close enough to the planet, but at the same time close enough to Moon A so that their forces actually cancel out. So first of all, when we are dealing with these problems, you should actually prematurely select yes, because when the AP exam asks these questions, this is really actually a does your answer make sense student. You should check your work if it doesn't. So if you select no, and if you still have time, definitely go back and fix your answers, because your answer is very likely wrong. If you select yes, well then support your answer. In the worst case scenario where you're running out of time, definitely select no and explain why you're wrong. But that would also mean you probably lose all the marks in part C, but you'd still earn all your marks in part D for consistency. Regardless, we should first prematurely select yes, and we should probably state something like, there is a certain distance for the expression FB such that the net force cancels out to 0. All right, there's definitely an algebraic solution to that. However, FA will always be greater than 0. Hence, when the two moons are close enough, but the planet is close enough as well to moon B, the net force expression for moon B will cancel to 0, while the net force expression for moon A will be a non-zero value. And that will obviously be greater than FB net. All right, so that will be our response to DI. Now, for our response for DII, well, that's a little bit different. Now we actually have to look at the other case. Well, in the other case, we could actually reason this with a bit of calculus. It actually allow you to do that. And it really isn't calculus, it's just us exploiting limits. You could really just say, if the net force, if moon A is really, really far from moon B, and the planet, the denominators are very big compared to the numerators, so the net force will approach 0. However, if moon B is very close to the planet, then the net force will obviously not approach 0. And hence, moon B will have a greater force exerted on it than that of moon A, validating my reasoning. And to be consistent, we should also add that sentence at the very end of this sentence. So we should probably say, hence, this validates our reasoning in part BI. It's always good to reference back to the question. And well, there you have it. That's how you would safely and easily respond to this 2022 AP Physics 1 Gravitational FRQ. I hope you had fun listening to this and you weren't bored to death. And if you think there's something that I can improve on, please feel free to email me or, well, send me a DM somewhere. Thank you so much for being with me, and I'll hope to catch you on the next video.